Okay guys, this is a continuation of the last SPI. We're going to continue talking about counting atoms and how ions are made and their oxidation numbers and why that matters for our chemical reactions. So why do atoms combine? That's the big question. Well, to be stable, an atom must have 8 or more electrons in its outer level. What is this outer level called again? What are those electrons called in this outer level? You should write that down. Anyways, atoms, the outer levels don't all have 8, but in order for them to be stable and to be happy, they're going to have 8. In order to have 8, sometimes they have to combine with other atoms to make them stable. So many atoms must combine with other atoms to become stable. Atoms can gain or lose electrons. Atoms can share electrons. When an atom gains or loses an electron, it becomes charged. A charged atom is called an ion. So we've talked about this before. We talked about the electron dot diagram like this over here, and that dots are showing the valence electrons, and they're all red. And look, you can see this one right here would fit so nicely right in that spot next to the other one on chlorine, and that would be what combines to make sodium chloride. Oh, it looks like I forgot to put the word ion in there. So a charged atom is called an ion, and the picture to the right is showing you how they combined and how they share that valence electron to make their compound. Alright, types of ions. Metals tend to lose electrons, so they become positive ions. The plus sign equals positive. Just a little reminder there. And then nonmetals tend to gain electrons, so they become negative ions. Ionic compounds. Atoms gain or lose electrons. A positive ion loses electrons. Negative ions gain electrons. For ionic compounds, they become good conductors. They have high melting points and are most are crystals. Those are physical characteristics of ionic compounds, and those characteristics are what happens when those two atoms join to make an ionic compound. Elements from families 1 and 2 will combine the best or most often with elements in families 16 and 17. We'll talk about that in a minute. Charge on the ion compound must be 0, so they cancel each other out. I think I left the word out off of your paper, so add that on there. Alright, and then covalent bonds. And if you remember when we took our last notes, ionic compounds are most often one metal and one nonmetal. And covalent compounds are most often 2 nonmetals. So atoms share electrons in their outer levels. What are those called again? So they form neutral particles called molecules, and both atoms can have a perfect 8. Forms 2 types. This is a continuation of covalent bonds, by the way. Forms 2 types of molecules. There's the polar covalent bonds, and that happens when one atom has more protons than the other. And you know protons carry a positive charge. Oopsie, that doesn't look like a plus sign at all. Let's try now. Then the other end, the electrons are unequally shared between the two atoms because it has a stronger pull. If one has more protons, so it has more positive charges, so it might have a stronger pull. Nonpolar electrons are equally shared between the two atoms. And then that takes us to oxidation number, and this helps us figure out which ones are going to combine and which one will make the perfect 8. The number of electrons an atom will lose, gain, or share in a chemical reaction is its oxidation number. So, for example, sodium, which we know is right here, will lose 1 electron. And we know that because, remember, this is group 1, so it has 1 valence electron, and so it's just easier for it to give that away so that it has a full shell without it. Whereas chlorine, remember, is right here, and that has 7 in its valence electron level, and so, or has 7 valence electrons, and so it wants to gain 1, right? It wants to gain or share 1. So, and we've used that example before. Sodium chloride is salt, and they join together to make a brand new compound. And sodium will lose it, and chlorine will gain it. And then another example would be like oxygen, which you know oxygen's right here. And oxygen can gain or share 2 electrons because it's in group 16, which 16 minus 10 is 6. There's 6 valence electrons, so to make its perfect 8, it wants to gain 2 or share 2. Alright, when those things happen, when it gains or loses or shares, that's the result of a chemical reaction. And there's 4 types of chemical reactions. There's synthesis, decomposition, single displacement, and double displacement. So in synthesis, 2 or more elements are combined. Synthesize means to make something, so if you're combining them, you're making something new. Energy is released when this happens as light or heat or both. Think of when we combined our baking soda with our vinegar and the bottle felt cold. That was the endothermic reaction, and the fizz given off and the air that was made, the carbon dioxide that was produced, that was a synthesis reaction. So I have some examples here, some simple samples like A plus B produces or yields AB. Well, you know that, or you can see that maybe in those letters right there. That's a simple way to look at it. An example of elements that combined would be aluminum plus oxygen. When they react together, they make aluminum oxide. And so that looks like that in words, or right below it is the chemical equation. So 4Al plus 3O2 yields 2Al2O3. And when we talk about balancing equations, we'll talk about how it gets to be like that. The next one we're going to talk about is decomposition. And decomposition, you know what decomposition means. It means to decompose, to break things down. A compound is broken down into a simple state. Energy is required to break these bonds. So AB yields A plus B. Or another example of that would be carbonic acid will yield or produce water and carbon dioxide. And then looking at the equation below there, if you have carbonic acid, which is H2CO3, and you break it apart, you're going to get water and carbon dioxide as the 2 byproducts of it, or the 2 separate compounds. Next, we have single displacement reaction, and a single displacement reaction means one element exchanges places with another element. So single means one, displacement means it moves. So think of it like that. One's going to move into a spot with another. Positive or negative ions can exchange places with one another. So for example, we have A plus BC, and what happens is what's produced is the C switches places and joins the A. So you have AC plus B. Single displacement, one letter moved or one element moved. Aluminum, silver, sulfide yields aluminum, sulfide, and silver. So what happened was the silver moved from here and let these two combine, and it became its own separate compound. So 2Al was your aluminum, and then it was plus silver sulfide, which was this part here. And then a chemical reaction occurred, and the sulfide joined the aluminum, and silver became by itself. That's single displacement. One element moves. And then we had double displacement reaction. So double displacement, guys, two things are displaced or moved. The positive ion of one compound replaces the positive ion of another. Two new compounds are formed. So AB plus CD, and what happens is the D switches places with the B to give you AD plus BC. So this one and this one switched. An example would be magnesium hydroxide plus hydrochloric acid. The magnesium hydroxide, that's your AB, and this is your CD. And when we had our chemical reaction, we got, let me get a different color out here. Magnesium is your A, chloride was your C, and then this is BD. So it gave us magnesium, chloride, and water. You can see what switched. The chloride switched with the hydroxide, made us magnesium chloride. Alright, so those are your 4 examples. Now, to learn how to balance equations, there's 4 steps you have to go through. First, you count the number of atoms of each element on both sides of the equation. So you've been doing that for like a week. We've been counting atoms. And you can count the total number. So what's going to happen next then is you determine which atoms are not balanced. Let me take this off right here. So you have your left side of the equation and the right side of the equation, and you separate each of those atoms. And you count how many atoms there are of each on each side. So on the left-hand side, we have 1 hydrogen, and on the right-hand side, we have, so there's our 1 hydrogen, but on the right-hand side, we have 2 hydrogens. So those are not equal. Chloride, we have 1 here. Oh, no, we have 2 here. So those are not equal. And then calcium, we have 1 here, and calcium, we have 1 here, so those are equal. So we know, by setting it up like this and looking, which ones aren't equal or which ones aren't balanced. So that's step 2. Are they balanced? The answer was no. So which ones aren't? We know it's the hydrogen and the chloride. So what are we going to do? Step 3 says balance 1 atom at a time using coefficients. What's a coefficient? It's the number in front. Okay, so then here, let me erase this. we have, we're going to put this number 2 right here. And so that gives us 2 hydrogen on the left side. We don't do anything to this side. There's already 2 hydrogen there. Then that gave us 2 chloride. So now we have 2 on this side. There's still 2 there. So we have 2 there. And we didn't mess with the calcium, so that's still 1 and 1. Is it balanced now? Yes. Okay. So after you put a coefficient there, you got to re-look at your steps and see, or re-look at your atoms and see if they are equal. That's the step 4. Check again. Okay. That's how you balance equations. We're going to do a bunch of practice problems in class coming up.